So I'm wondering, you guys all came from a background like this hippie culture and making stuff out of nothing and whatever. You probably would have been building straw bale if you were out in the West, but how can we sort of merge back this sort of super high-tech knowledge into something that's more local for New England? Like, what is the sustainable New England house, and does it have to be so high-tech?
So you know where there's, I think, the best thinking on that? You might have a different...
Could you repeat the question, please?
Yeah.
We couldn't hear the question.
Oh, sorry.
I think the question is how do we grow a local New England construction culture that is not a high-tech imported gizmo construction culture? Is that a reinterpretation?
Yeah, fair enough.
So there's a group that's the Natural Builders of New England, and NBNE, and I think some of the leading people in that group, Ben Graham, Jiva Rakison, who's just written with his partner another straw bale book. They're I hope it's fair to say this. They're not purists, so it's really important to them to have the lowest impact materials and assemblies, but it's important to them that it work. And so both of those guys have gone through the Passive House training. They've blower doored and infrared scanned a bunch of their buildings. And I think that's where it feels to me on the grassroots level, that's one of the places where there's a leading edge, figuring out how to use very low impact, very local materials, but still make really high quality envelopes. Because some of the failures on the early, I mean, I've done failure analyses on straw bale houses in New England already. So you can screw that up pretty easily.
And I think, to answer the question that Chris Corson's this morning presentation with the white pine from Maine and the cellulose walls, there are a lot of New England builders who have settled on cellulose insulation, which comes from relatively nearby, and don't buy European windows, although Chris was using Intus windows, but trying to buy from local mills. So, these are there's fairly typical ways to use kind of New England techniques.
I'd also point out that the folks Mark was just mentioning, particularly Jacob Deva Rakusin and Ace McCarlton, have just published a book called The Natural Building Companion, which is excellent. Excellent.
Yeah, I've got a question back here.
Right. Well, I want to actually hold. I don't want to break it open too soon because there's a couple sort of big picture things I want to just get through. Which is, we're here at Passive House New England, but I'd love to each you to fill in. Like, what do you think? What is your goal that what do you think we should be working towards? Is it net zero? Is it net positive, sort of a regenerative piece? Is it Passive House? What is the for each of you, what's your touchstone on where you're headed?
Well, for me, it's about in the big picture. Honestly, it's about large scale, trying to change building type by building type how we approach that. And as far as in this country, if I can just get them to focus on things that are affordable, and they can build a better building that's going to be around for a long time, and that'll get them close to where they need to be for net zero. That it's about showing that can be done in an affordable, efficient manner, and that we don't have to be building the same crappy buildings that we've been building for 50 years. So that's my thing. Is I just want to prove to people in the next 10 years that all these different types, every new school should be a high-performance school.
Go ahead.
Well, I'm probably the only one here that doesn't have a certified Passive House in his portfolio. So I may not be qualified to speak on this. But I think that arbitrary standard, that'd be nice, actually. And I now have a piece of land you could put it on. I think arbitrary standards have both risk and benefit, and the risk is that you do things blindly to meet the standard. And I think I feel like what I'm seeing in early Passive Houses definitely exemplifies things where, we just keep turning the dials we can turn until we hit 475, and it doesn't. The results don't necessarily make sense to me. So I think there's that piece about, putting it through a filter of what makes sense rather than a filter of what gets to an arbitrary threshold of support.
And how do you measure that? What makes sense? I'm curious.
Well, that's a great question, but I have an answer.
Yeah.
It's not a good answer, but I have an answer. So my axe to grind is what I call resource equity, which is that if you're going to have a standard, it's per person, not per square foot. Because the way that the code has been improving, IECC, I think that it's reasonable to say that a 1,200 square foot, three-bedroom ranch built in 2012 IECC will probably use less energy than a 4,000 square foot passive house. So you really, until you have a standard that is not per square foot, but it's per square person, per person, square or not. I mean, I'm fairly square at this age. Then I think you're missing the boat. And if that standard isn't defined in primary energy, I think you're missing the boat. We are focusing on heating, the annual heating demand as we get further north I think is not a wise use of resources. So that's my axe to grind is resource equity, building size, and having some kind of sensible filter. And so, yes, it's a huge debate on where that level is, but you guys are having that debate with your pretty good house.
I just wanted to hear your opinion on
But,
it.
but you know, like what you showed, right, with like your apartment building that burned down, the guy had $100. You built the best building you could build for $100 a foot, right? I mean, so if that's a limitation, and you know that building's only be rebuilt once unless it burns down again, right? So you build it. If that's the budget, it does you. Well, it does you no good to design a building that's $120 a foot if he has 100 to spend, right? So you design the best building you can at that budget. Now, ideally, we'd like to push as hard as we can, but it's better to build it as good as you can than to just fall back and say, well, if I can't do this, I'm just going to do that, you know, that other. I mean, I think you made that point really well in that presentation.
And I'm going to be a little bit of a contrarian, and I'm going to disagree that it's not always best to push as far as you can. And I'm going to side with Mark that we have to look at where our standard is leading us. And sometimes we have to just back up and say, whoa, is this making sense? And the trouble with the Central European Passive House standard applied to New England and cold climates is it's not making sense. And we're doing it for the best of reasons, in theory, to save the planet and lower our carbon footprint. We're ending up with these extremely wasteful, large, single-family homes that we're spending an extra, in many cases, $50,000 worth of materials that are yielding very little in energy savings. And so then that's where there's a certain gospel. The PHPP number has got to, you know, be yes at the end. And the gospel is interfering with just simple, plain analysis, which is, does it pass the smell test? Does it, how many BTUs am I saving for this $1,000? How many BTUs a year?
Well, Mark,
kilowatt hours.
I think,
Let me finish.
Sorry.
So, and, you know, I've always said that, you know, the net zero energy approach uses the PV investment as the benchmark. You compare those new windows, that extra foot of insulation, the extra 4 inches of foam, you have to compare it in how many kilowatt hours per year you're getting for that investment compared to the PV. Now that's a moving target, and it just dropped by half in the last 3 years. You know, we get twice as much electricity now per $1,000 investment as we did 3 years ago. So at some point, that's an arbitrary thing too, and PV alone does not solve our winter energy problem. I know all this, but at least it was based on something. And people who are getting these net zero energy houses for $200,000, like Carter Scott, I think are using resources more logically and efficiently than people building $300,000 passive houses or $400,000 passive houses. So why do we hit these PHPP numbers? Not for any reason that we're getting a good yield in energy savings on our investment. And ultimately, the planet can't afford stupidity. Our planet is in a crisis. We have so much resources to invest in as human beings to cut the carbon. And new passive house single-family homes are not a wise use of our investment dollars if we care about carbon. So it's okay to care about carbon. But you know, building these new homes is not a good way. You know, retrofitting our coal plants, taking our coal plants off the market, changing our transportation infrastructure. We all know the list of those wedges which are good investments, and passive house isn't one of them. So anyway.
well, I mean, I don't disagree with some of what you said, but I do disagree with some of what you said. First of all, if I look at the European model, right, a lot of the passive houses that are claimed to be passive houses are not 475 passive houses. They're not certified. They just use passive house principles to create the best building they can for the money, the investment. There are certain things within the passive house methodology that I think are extremely important for building durability and for thermal comfort that I think we ought to take into account, okay? So sure, you might be building a house that has a demand of 8 kBTUs per square foot, whatever, it doesn't really matter. You're still building a good house, as long as you're not having potential for condensation and mold on the interior behind your, or behind your couch, because all of a sudden you're creating convection because you have too much delta T in your room. So I think there are certain principles built within the physics of the passive house methodology that are really important to pay attention to.
But Dr. Feist has exaggerated that point.
Well, no, I think, Dr. Feist has said on more than one occasion, don't meet the 15, just be whatever and call it a passive house. Okay? So, I think Kristen, you weren't there. He said it to you.
He did.
He did? Okay.
He said that the most important thing is to build the best buildings that you can.
There you go. So I think there are things within that methodology that are really important to build a good building, but hitting the 4. I think I totally agree with you. Hitting 4.75 is not necessarily that good a thing.
The passive house methodology has given us an awareness of things that we haven't paid attention to in general. And I won't even say airtight, because, I mean, my house in the late 70s was airtight, was aimed to be airtight. But the thermal bridges, like no one looked at thermal bridges. The amount of us that were paying attention to bridging and used therm before passive house came into this country were people who were analyzing windows. Right? So the number of people, the thermal bridging has been a big contribution. The part of that spreadsheet that shows where the energy is going, where the loads are, is really useful. Because even in the course I'm teaching, where I've made these little calculators that can be used in 5 minutes instead of 5 days, people are saying, oh, I never was able to, I never knew that if I change this, it has this much effect, or if I change that, it has that much effect. So giving some, there's nothing magical about PHPP, but it is transparent. It's not, you can see what they're doing. That window, those few cells that show the energy balance through the windows, what a wonderful tool early on in design to see what you're doing. So spreadsheets are so much more useful than REM rate, sun code. How many have I used in 30 years? Because immediate feedback, not even a run. And the days when we started this, we started the simulation, and then we went away for some hours, or some days overnight, and then, oh shit, I made an error, an input error, and that whole evening's worth of calculations were like gone.